the... Okay, thanks everyone for joining. This is part 2 of our Ethereum transactions workshop series. Last week, we looked at verifying contract. This week, we are looking at decoding input data. And Chichon, take it away.
Right, hi guys, welcome back. My name is Chichon, for those who do not know. And for those who joined the last week's workshop, I hope you guys had fun. So this week, we are going to venture into another contract-related part of Ethereum, mainly the method calls, and hence the title decoding input data. So without further ado, let's start. So a bit of recap from last week, what we did last week for those for the benefit of those who missed it and would like to know more. Last week, we have successfully created and deployed a smart contract using 3 different tools: Remix, Truffle, and Hardhat. The steps are in the video. I believe it has been posted out in the official ETHKL YouTube. So for those who would like to check it out more, you can always go there after this session. And we also try to look into verifying contracts on Etherscan and Sourcify. And we look at the contract, read and write contract interface using Etherscan. And how do we do that using Etherscan's interface so that we don't have to write codes to manually interact with the contract that's been deployed. And at the end of the session, we also look a bit on the ability to inspect the code, the input data, and also look at event logs for a contract that's been verified. And today we are particularly interested in the input data part. Event logs, we will do it in the next session. And before I officially start, for those who have questions, feel free to leave them down in the chat as you did last week. And I will just look at it. I'll just screen through a chat from time to time and answer your question if I'm able to. All right. So let's begin. So now what we really want to do is that we want to look at how input data look like. So this is a transition that we have performed last week, right? From the contract where we plot in COVID. I use this example because it's something that we are familiar with. So it's related to last week's workshop. And right at the bottom of the screen, you can see that this is input data section, and it's nicely written out for us that, hey, this is the function name, this is the parameter name, and the method ID, and this long list of zeros, and at the end is ends with 5. So we're going to understand what is this. And well, we all know from last week is this data will only appear in such a form when the contract has been verified. So if the contract has not been verified, we will get something like this. So this is essentially the input data that the user is sending to the blockchain when they are trying to interact with this contract. And we are going to make sense of the meaning behind this thing. So yeah, there's a way to read it. And our end goal today is to be able to understand this one, and we'll at the end of the session, to make things a bit more fun, we'll look into Uniswap B3s and multi-call. I will pick up an example. We'll try to decode that input data as well. So for those who are more interested, you can stay tuned on to the Uniswap B3 section. I won't talk about the workings of Uniswap B3. It's just the decoding input part, because Uniswap B3 is a bit more a bit more technical. So we just look at the decoding input part. All right. So our end goal is to understand what's the meaning of this thing, right? And the answer should be, and the result, let me see, should be something like this. Cool. So over here, I have the input data. I have the function names nicely shown to us in Etherscan, the method ID, as well as the parameters that we are passing in, as well as the type. So yeah, at the end, we're trying to make sense of that. Oh, zoom. Okay, sorry guys. Oops, how do I zoom? How do I zoom? Oops.
View, top left view.
Oh, okay. As you can see, I have hardly used is it a bit too big?
There's a magnifying icon just below the insert button.
Where? Here.
No, get out from the menu.
Okay.
There's a magnifying. You see just
here?
below insert. To the left, just below the insert button. Left.
Here. Okay.
Yeah.
Okay. Fine.
Yeah, you can do in and out.
Okay, this is not helping. It's 100 fit. Is it big enough for you guys? No, it's too big. Can I default it to
200 is fine, I think.
It's okay, but it's huge for me to navigate. But yeah, let's do 200 then. I will bear with me as I scroll up and scroll down this slide. Yeah. So yeah, sorry for the bit of a issue. But okay, recap. Input data will look like this, and we will understand how does this goes to something like this, and we will understand how does this go to something that contains parameters of this data type and name. Okay, so that's the end goal for today's workshop. All right, so let's first talk about method ID. What is method ID? Now, method ID is actually a fancy name to say the cache 256 of the function and its parameters. And take note, it's only the first 4 bytes. Okay, I know that sounds more fancy. So let's example. This is the sort of like a text signature. It looks like the method that we are going to call, right? This is the name of the method, and this is the type of the parameter that we are passing in to call this method. The method ID is simply the hex, the partial hash of this thing, and it will give us this thing. So basically, this hash over here means that it's add to current number. This is a function name with uint 256 type. Can you share the docs link instead? It will be easier to read. Because it's in my private docs. Can I share it after the session? I'll share it to Harif and he can broadcast to everyone who needs it. Check if it's okay for you. Okay, nice. I will share it after the session. And where was I? And take note that this is only a partial of the hex. Hence, I mentioned the first 4 bytes. So what do I mean by that? Okay. So over here, there's an example. So let's look at this function name called min with a 1, 2, 3, 4, 5 with 5 parameters, 2 uints in front, the address, string, and followed by address and then address. And the parameter names are A, B, C, C. It shouldn't be C, it should be maybe something else because the parameter is going to repeat. Maybe it's D and E. And what we do to get the method ID is first we remove all the A, B, C, Ds, and E's, the parameter names, so to say, and we will get something like this, right? And then we apply a cache 256 hash. So for those who are not familiar with hashing, it's basically we are converting this into a unique string using some cryptographic calculations, and this thing basically will be hashed to something like this, right? It's a very long looking string of text. There's actually a standard for cache 256. I'm not going to go into that. But after hashing, what we are really interested in is actually the first 4 bytes of the resultant hash. So the first 4 bytes is actually 1 byte, 2 byte, 3 bytes, and 4 bytes. It's df08b714. So this one will essentially be our method ID, right? There are reasons as to why they only take the first 4 bytes, such as save a bit of gas when they call. But that one is I won't go into too deep into that. But one thing to note is that because it only takes the first 4 bytes of the hash, there's a chance of a method name having collisions. Therefore, looking at this df08b714, there is no way to know for certain that this thing means it's a min function with these parameters. It could be something else that so happen coincidentally shares the same first 4 byte, but the rest of the hash it's completely different. There is a possibility. But because this thing is only important in the smart contract environment, the scope of a smart contract, so the possibility of a collision is rather low. And when you have a collision, when compiling so happen, maybe you have a collision function, maybe I don't know, maybe you're lucky or unlucky, you generate the same first 4 byte when you select your function name, your compiler will fail. And how is it being used in when you call a contract? So this is an example. Okay, I'm going to show you this simple code first. So this one has two functions, set A and set B. So we know both of them will have a different method ID already, assuming that they don't collide, which is very low, a fault likelihood. And in the opcode, this is a comment opcode. So when we first call data, right, the first part of the first part will means that we are extracting the first 4 bytes, hence 0 to 4. We are getting the first 4 bytes, and the EVM will have an if-else statement. So if the first one equals to this method ID, we will jump to set B, and else it will jump to set A. So this is a brief overview on how the EVM uses the method ID to call the correct function. And I stole it from someone's article shamelessly. I didn't write this. And so now that we know how to generate, hang on, I think it's better if I show an example. So there is a list of public dictionary that we can use to sort of search for the method IDs, and it's called 4byte.directory. It's free to use, it's public. An example, if I were to copy this one because they already have this record in there, right? So if I copy and paste this one, it will spit out, it give me the result that so happen this one has the method ID of this one. And take note that this website that do not have all the byte signatures, that does not have records for all the method IDs. It's just the ones that people have contributed and uploaded to the site to use. So there are likelihood that your method ID cannot be found here. Okay, and so to demonstrate that this thing is in fact this thing, let's copy this, and I have a kcheck256 online tool that you can use. So it will, oops, I have to remove the spaces, and then I take the first 4 bytes. So 1 byte is equals to, because this is hexadecimal, so 1 byte will be equivalent to 2 characters. So 1, 2, 3, 4. You can remove the rest. So and then we have to add a 0x, and this one will be our method ID, df08b714 and df08b714. Right. So that's basically how the method ID is calculated. It's from the function name along with the parameters, not including a parameter's name. Not including the parameter's name, you can name anything that you want, and as long as this one and this one are same, and then you make and then you just make it in this form, and then you check 256 it, and then you take the first 4 bits and then you return it to the method ID. All right, so that's how we get the method ID and how it is being used in an EVM. Next up, we look at input data, which is slightly more interesting. So another repeat of the examples that I used ago. So this is input data, and now we know that the first 4 bytes will always be the method ID. What does the rest of the remaining byte mean actually? So okay, this one, there is again no easy way to know. And if I'm only given this one over here, right, I wouldn't know that this is actually 5, because it could be some other types. It could be maybe what types do I have? Maybe in, or instead of u in, because I wouldn't be, in other words, I wouldn't be able to guess the type. Okay, in this case, it's an example. But if it's more complex, right, I wouldn't be able to guess the parameter types, judging using only the information I'm given here. And hence, we need an ABI. ABI, it's a kind of recipe that tells us that tells us how the function and the parameters looks like. And from ABI, it's something that we looked at in last week's workshop. So ABI is very important when you interact with the contract, because without that, right, you wouldn't know how to translate your user readable data to this encoded form. So, okay, and take note that each input data will have a length of 32 bytes, and 32 bytes is 64 characters because it's hexadecimal. Okay, next. So looking at the previous example, we know that it's already a uint256, right? So the 0, 0, 0, 0, 0, a lot of zeros, and 5 will be converted to 0x5. And if I use the hash convert, the hexadecimal to a decimal converter, I will get that my underscore to add is actually 5. So that's a simple look at how you decode a uint parameter type. Now the same concept applies to other addresses, other types, which includes addresses, Boolean, but arrays, for example, bytes, strings, or maybe uint will be a bit different. Okay, it will be a bit different, and we will look into it. And sometimes if you see because this is unsigned integer, so if you see integer, right, you need to use this thing called a tools complement to convert it. That means you cannot assume that this thing is 5 anymore. You have to apply the tools complement to convert the bytes to integer. This is a calculator which you can use. Tools complement is a way to handle negative numbers in computer languages. For computer to read, negative numbers. Okay, now let's try another example. Now I have a slightly more complex example. The function name is test function, and I have 1, 2, 3. I have three parameters. The first one is uint256, address, and bool. And the input data that I have now is this long text over here. So very long text. I'm going to, don't mind me, I'm going to just make it smaller for just this slide. Okay. And if I do not have this, let's say if I were to delete this, oops. Let's see if I were to delete this, there's no way for me to decode this, because this thing could be, we want to be sure that this is the type address, right? It could be something else. It could be maybe a string, maybe, who knows? Oops. Okay. So the first thing we do is we split out the method ID, which is the first 4 bytes. So we remove this part. Okay. And then we separate the remaining characters over here by 32 bytes. So the first 32 byte will be here until here. So it's this one, 00003. The second one will be here to maybe wait, hold on, I'm trying to find here. It's answer 48. I've already done it here. And the last one is this one, because it's okay. And then we know that the first parameter that we have is 3, and it's a type uint. We can, let's do it for the sake of a demo. Hex to decimal converter. So it's 0x3. Convert, it will be 3. So the first parameter that we have over here that the user inputted was 3. And address has a fixed length of 20 bytes. So the input data will append the additional 12 bytes with zeros, and so the rest of it will automatically be the address. So in this case, the address will be 0x80b 869916, and so on and so forth. Boolean is only 0 and 1. So in this case, it's 0, and therefore it's a false. So from there, we can see that the actual data that was being passed in was 3, 0x A0b ... B48, and false. Okay. So a quick. Okay, so everyone okay? Yeah, awesome. So a quick recap. We need to know, it's important for us to understand, to have the contract ABI that includes the recipe for the type of parameters that the user call, and with that we can confidently say that this one will be decoded to the user readable types. So that's how we do it. Okay, moving on, we'll be looking at bytes 32. Bytes will be a bit different. Now, notice that before that, right, this and this and this one, if it's true, it'll be hit 1 over here. they are called little endian. You don't have to remember the name. It's just that the values that we are interested in will start from the end, right? You start from the right. So this one is start from the right, this one starts from the right, and this one starts from the right. But for types like bytes, it'll be different. It starts from the left. They call it the big endian. Don't worry about the name. Just bear in mind that this one starts from the left. So in other words, this function with this type and this input type, let's split the method ID out. Oh, I copied wrongly. Never mind. And this A, B, C, D, this one will be the byte, and it starts from the left. So we can just remove all the zeros behind, and so it will be 0x A, B, C, D, E, F, A, B, C, D. Just note that bytes will be different. And arrays and bytes and strings are also slightly different, right? From here we can see that I have an input of 1 and 2. And this is the type, right? It's uint256, and this square bracket basically means that it accepts the type of an array, and it's longer than what we expected, right? Because there's only 2 numbers, we expect it to only have maybe 0 and 1, but we have 0, 1, 2, 3. So what is going on over here? Now, EVM has a different way of letting itself knows that, hey, this is an array. First up, if it's an array, the first 32 bytes here, right, will be converted to uint, and it becomes 32. And this 20 basically means 32 in decimal. So because it's in hex, right? So we have to convert it to, so it's 32. And the second 32 bytes will be 2 here, and it means the length of the array. I'll talk about this one later. And the third and the fourth will be the data that we're interested in. Okay. And what do you mean by 32 over here? It means that we have to get to the array, we have to offset it by 32 bytes. So the length of the array will appear 32 bytes later. So from here, 32 bytes later, it will be here. So we know that, hey, this is the beginning of the array. And the array says, and this one says it's 2. That means we will be expecting a length of 2 array length of 2 array. So in this case, this one will be the first one, and this one will be the second one. So array is a bit tricky. It has these 2 parts. It will tell us where to start the array at, and it will tell us the length of the array. And because this is 2, length of 2, so we have 2 input data that we can be expecting. So this one will be 1 and this one will be 2. So yeah, array is a bit different. And bytes and strings are similar. Let's look at bytes. And let's say that I have another function, it's test, and I accept parameters with a type of bytes. This one is a typo. And this is the input data, right? And this one is also a typo. And the first 4 bytes over here will be the method ID. So let's ignore that. And then we separate this thing out into 32 bytes each. So this one will be 32 bytes, followed by this one, and followed by this one. Okay. So I have formatted it for you over here. And bytes, the first 32 bytes will also be the starting bytes that we are interested in. So in this case, it's 20. So we will start 32 bytes later, which is here. And this one will be 1. So it means that we're expecting a 1 byte length bytes. And 1 byte length 1 byte basically has 2 basically can be represented by two hexadecimal alphabets. And so we can, this one, 0A, basically means A in a 0xa in a byte form. For string, it's similar. It's similar to this thing. Oops. It's just that the final outcome, right? We have to convert it to UTF-8. So we can rely on this online tool. We can rely on this online tool, and then we just convert 0xa to UTF-8. Yeah. How do I convert it? Oops. It's not working. Yeah, fine. It should convert, but I don't know why. Maybe I typed the wrong thing, but it's fine. So yeah, for string, we just need to convert this to UTF-8, and then it will show the string that we are interested in. But it will still follow this format. This one will be the first byte, second byte, third byte, fourth byte, and this one will reflect the length of the bytes that follows. And if the bytes and strings are too long, like for example, it's more than 32 bytes, we will have another new new set of 32 bytes to describe the to describe the to fill in more data, and this one will reflect it tells like how long will this entire thing be. So yeah, this is how bytes and string will work. So yeah, basically I covered most of the types, and some of them are a bit more confusing than the rest. And before I proceed, right, any questions? Why would smart contract use type byte instead of uin or in? Because sometimes uin and in, they can't represent a lot of things, right? Bytes can do a lot of things. For example, you can convert it. We'll look at an example at for Uniswap v3 that accepts an array of bytes, and from there they will format it out to the respective type. So that's one of the example. Bytes can format to maybe address, can format to string. You can put together a long list of things, and it's also a bit more efficient, to say, a bit more gas saving if I'm right. So okay, so finally let's look at Uniswap v3 multi-core contract, and this is an example that I copied so that I don't forget where to find. And if you look at the input data section, right? Okay, let's first look at the contract that we are interested in. We have this method column that shows the method that we're calling. But if you look at the method only, everything is calling multi-core. The transaction will be doing different things, but the main method that is calling will be multi-core. Why? Because Uniswap v3 uses a library. It's called the multi-core library, and users will pass in. Users can interact with a couple of functions in the same transaction by doing this. So if you are like maybe swapping and maybe refunding ETH, they'll do it in one transaction for you, and they'll use this method, and they will put what to call inside this method to execute it in one transaction. So you don't have to like call 2 times, and maybe the price will change and stuff like that. Okay, yeah, so here's the part that we're interested in, right? It's calling a multi-core, and let's look at original. This is the original code. I'm gonna copy it to Notepad. Where's my Notepad? Right here. Okay. Actually, I'm not going to copy it on Notepad. Sorry, guys. I am going to use this thing called Decode text splitter, because it's a very helpful tool that helps me to decode. You see? Okay. Oh shit. Okay. So we know that the first 4 bytes, it's basically the method ID, right? So we feel free to just remove that. 1, 2, 3, 4. Just throw this away. And for the remaining text, we just split it by 32 bytes. So because 1 byte is basically 2 hexadecimal characters, I'm going to split it by 64, and I'm just split. And yeah, there you go. This is the nicely formatted stuff for us. So now let's look at what it really means. For that, we need to know the function, the parameters type that is passing in. So it's bytes, array of bytes. So this thing will be an array of bytes. So we know that for an array, the first thing basically means the number of bytes to skip. So it's 20. So 20 will be 32 bytes. So we have to skip this one by 32 bytes, and then this one will be the length. It will be length of 2, right? So we can expect 2 bytes, 2 element of bytes has been passed into the array, and this 2 will be the byte. Okay. But what is going on here? Like, shouldn't it end over here? What are the rest of these things? Now remember that we are handling bytes. So bytes, if you recall from here, right? Bytes will have this format. It's something like an array, but you can think of it as an array in an array. So this one will basically also be the pointer, will be the offset. You offset by 0x40. So let's convert it to hex to 0x40 is 64 bytes. So we will offset by two columns, 1 column, 2 column. Okay, we'll start here. And the next one, because it's length 2, right? And we expect 2 bytes have been passed in, right? This one will be the first byte, this one will be the second byte. The next one, 1E0, will be. Sorry guys, if a bit more technical, feel free to put your questions down in the chat so I can explain them clearer. So we offset in by 4,680 bytes. Okay, so we look at the first one. This one is we offset by 64. So 1, 2. So this one will be the starting of our first byte, and it has a length of 0x164, which is 356 bytes. So the first 356 bytes is something that we're interested in, right? And this is obviously more than 364 bytes. So it will stretch out to the second group of 32, and again stretch out to another 32, stretch out to 32, and then until it's here. So let's perform a calculation. How many 356 divided by 32? 11.1, so it's going to be 12. So where was I? It's very confusing. 164 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 1, 2, 3, 4, 5, 6. No, sorry, wrong one. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's right. Here. So this stretch of data will be the second byte that we're interested in. Okay. And what about these two? Now remember that previously, right, we have two offsets. One is this one, which is the first stretch of data. This one is the second one that we're interested in. And if you were to convert 1E0 480, and we 15. So we offset by 15. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No, wrong one. Sorry, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 12, 13. Hey, what am I doing? What's going on? 40, it's here. This one, it's. Let me figure things out. Sort of got confused. Confused myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Yeah. Then I calculated wrongly. Yes. So by offsetting to 15, right, we'll get here. We'll get to here. So this one will be the second element that we're interested in. And because the length of this is 4, so this one will only be 4 bytes, and there's no need to expand it beyond 32 bytes. So basically, in other words, it has 2 bytes, right? The multi-core that we are interested in has 2 bytes, and each byte, and if we were to look at this, right, the first byte will have this one. The second byte is here. So yeah, so this is, and the second byte is easier to look, so we look at it first. It only has length of 4 bytes, so 122.1.0E8A will then be the method ID of the function it's calling. Now, why is it the method ID of the function it's calling? Now, because after decoding the data into its respective bytes form, multi-core will call delegate call, and delegate call will automatically just look for this thing, right? Treat this as an input data, and then you will call the function again. And therefore, these first 4 bytes, 1, 2, 3, 4, will be the method ID for the function min, and the rest, you can decode it as we did just now to get the respective values, just like how Etherscan did it over here. In this case, it's a bit shorter because there are no inputs, because this one has no parameters, so there's no need for input. So method ID in this case will be suffice, and the function is called refund ETH. So doing it manually, it's hard. Like as you can see just now, I did a couple of mistakes counting in front of the audience, but it's possible, and this is how for those who are interested in reading more details, so this is how you do it. You get the ABI, and then you follow the format, and then you get your results. And yeah, that's how the EVM read it. So it's for machine to read and not for humans to read. That pretty much concludes the session. It's a bit short, but I hope it's not too confusing. Any questions?
Can you walk through an example of a transaction, let's say on Etherscan?
A random transaction?
Yeah, maybe not multi-core if it can be too confusing.
Let's see if this is a contract. Oh, this is not a contract. This one looks like a contract. It's also multi-core. This one also looks like a contract.
Maybe you can.
Yeah, this one. Do you want to look at this one?
Yeah, sure.
Okay, I'm doing it live. I've not done this transaction before, so bear with me, guys. So okay, first thing I'm going to copy it to my notepad. It's going to be very long. And we can remove the first 4 bytes, 1, 2, 3, 4, because that's going to be a method ID. Just remove that. And the rest of it we can separate it by 32 bits. So let's do it. Yep. My trusty text splitter. Split. Okay. So this is what happens when we get free stuff. So this is the remaining input data with 32 split by 32 bytes. So this one will be the first 32, 32, and so on and so forth. Okay, third thing that we need to do is that we need to know the types that we are going to expect, right? Over here, I'm going to cheat. I'm going to look at this type. So it's the first one is a uin256. Second one, uin256. This one, third one is an array of address. Fourth one is an address, and fifth one is an uin256. So basically, there are a lot of uin256 and one array and one address. So it's not going to be too difficult, thankfully. So let's look at the first two uin256. So this two is going to be let's convert this to uin256. I mean, yeah. Okay, for that, we use this one. Yep, correct. So the first input that the user has inputted to by calling this contract is this long number, judging from this one, right? The second one will be this one. Remember to always append a 0x to this thing. It will be this one. So from here we know that the amount in is it's 4430 something, and the minimum out minimum, I think it's calling Uniswap. Yeah, it is. The user expects to have a minimum out amount of this number of tokens. Remember, we have to divide it by the decimal places. It really depends on the contract that we're directing, right? I think this is, I'm going to cheat. It's, I don't know decimal place for Poon, so I don't know if it's 18 decimal place or some other things. Okay, what you do with the decoded data for your smart contract development data mining? What do you mean? What Etherscan do? Or what do I do personally? If there are more. Okay. While you answer that, let me go to the third. What do we do personally? I wouldn't do anything, right? I would just use this tool. I would decode it, and sometimes if I want to know like what the user call, or if I want to call the contract manually without interacting with anything, right? I would just look at this. Let's look at this and try to replicate this call. It's basically not very functional. It's more on understanding how it works. So you can understand how the contract works. By decoding this, we know the input that is being passed into the contract. And to understand how the contract works, right, we have to look at the contract code and then we play each step. So we know that the user is inputting like this kind of stuff, and we look at the contract code, we can find it. I'm going to copy this, show you the contract code. Find this here. One sec. Find it here. So the user is basically calling this function. It's an interface. Yeah, this function, right? And then from here we look at well, where is this amount one being used? It says that we are safe transferring amount one. So amount out min. So we get it from here. No, amount one. We get it from we check for the required thing and so on and so forth. So if you really like to know how does the input parameters interact with the contract code, we have to come into the code and just understand the logic of the code. And as you can see, this one over here, they call some other contract. So you need to jump on to maybe transfer helper to look at what does safe transfer from do. So even as a non-dev, I could use the function to interact with the contract directly. Yes, because this is deployed publicly, right? But this is decoding the input data itself is a hassle. So encoding it will also be a hassle. The easiest way to interact it directly is to use Etherscan's read and write contract functionality. We have already done it for you behind. You just need to type in the user readable text. Or make clones of the contract. Yes, you can just copy this and just deploy it. That's what a lot of people. That's what a lot of people does, right? And for SushiSwap, they copy this one and stuff. Some people just copy this without even bother changing the contract name. Yeah, you can make clones easily because it's public data, right? But whether people would want to use it or not, it's another story. But you can clone it and you can sneakily change some of the code to. Okay, not recommended, not good, not ethical, but you can. Okay, sorry. Now, we stop at address array path. So this is a bit tricky, it's an array, right? but we just have to bear in mind that the format of an array. Sounds pretty useful to reverse, yes. Address array path. So let's look at our text splitter. It's the third, so this one, right? And because I know there's array, right? So this one, I know that it's going to be offset by A0. So what's A0? As you can see, I'm not very good at converting a hex to decimal in my head. 160. And I'm also not very good at dividing stuff. So I need to do this. No, this is something I want. So it's going to offset by 5 arrays. Okay, 5. So now we look at this. 1, 2, 3, 4, 5. No, 5. Is it 5? Sorry guys, let me double check. 1, 2, 3, 4, 5. Yeah, 5 here. Hey, no, it can't be right. 1, 2, 3 should be here. Or why is it here? Did I calculate something wrong? Let's try again. No, it's correct. Divide by 32 is 5. Weird. Anyway, ignore that. Embarrassing. And 1, 2, this one. Okay, it will start from here. And this one will have a length of 2, which tells us that this one and this one are the arrays that we're interested in. And because they are addresses, right, we can just get this thing and put a 0x in front of it. And then it will be the address. So because this is the path and it's Uniswap, I already know that the function of path is to define the hops that we want in this swap. So we are just directly swapping from this one to this one. And this one I know from experience that this is a WEF. So the user is transferring Groon token, swapping Groon token and WEF token. Okay. Let's look at the other 2 parameters. Address and deadline. So the next one, 1, 2, 3, 4, this one will be the address. Oh, this is a very unique address. This is a lot of zeros in the address. I need to get the length. This is annoying. It's 32 bytes, so I need to minus by 12 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it correct? I don't know. Let's try. Oops, wrong one. V1. Damn. Let's try again. Should do this string length online. 64. Why is it so long? Length of contract is 40. So I'm going to minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it correct? Yep. So it gives us the let's look at what address 2. It's transferring to this guy, right? Yeah, this is what happens if you do it live. Sorry, guys. Oh wait, did I do things wrongly? Oh, sorry, guys. I read the wrong field. Yes, Alex, thanks. Yes, it's the third field. This one. Yes, you guys are right. This is the field. Yeah, so just really using this and yep, you're right. Thanks. And the last one over here, it's the no, sorry. This one was the length. This one we just have to convert it to uin, right? To uin. And this one will be the timestamp, the deadline for the call transaction to expire. So yeah, is how we would understand this one from a function in Uniswap from its parameter. Okay, can change the date to normal here. So because epoch is always in the UTC, I can convert to human readable date. So that means this transaction will expire at June of 19, 5:32 p.m. Malaysian time. So it haven't expired yet. So that's why it's successful. Yeah. Okay. That's a walkthrough of an example transaction.
Chichuan, so
Yes.
what if there is an unverified contract that's being interacted?
For a verified contract, we could only guess because we don't have the ABI, right? If we somehow could know the ABI if we somehow could know the parameters of the function, we could use employ the same technique to decode to human readable input data. But generally, unverified contracts, the ABI is not known. So there is no 100% way to say that, hey, this is going to be the actual input that the user has inputted. We can only guess, but it's not 100%, right? Because we may guess wrongly. Some things will be decoded wrongly and stuff. We could guess.
Will you be showing event logs as well?
Will be next week because Levox, I leave it for next week. Yeah.
And can you run through the Ethereum messages like sending string?
Okay.
Transactions?
Yes, I do. You have the example transactions?
Oh wait. Can you go to VB address?
Totally forgot about that.
Scroll down.
Oops, sorry. Oh, yours. Okay.
Okay.
The first.
I think there's one that was sent to 0000 dead.
This one.
Yeah. Is it this one or
Okay. Yes.
another one?
What? Yeah, this one. So what Harif was mentioning was how the users input text into an Ethereum transaction. So how indeed? For this, I'm going to use MetaMask. So in MetaMask, there's an advanced feature that we can. I'm going to be careful here to not show my private key. Advanced feature, and we can show hex data. No, I mean, we can toggle this button here off and on. I've already on it. So if you toggle that, right, what happens is that if we try to send a transaction, let's say I'm going to transfer to whoever, to myself. See, and now I have a hex data column over here. So previously, if you don't see it, if you don't turn it on. So this column is something that we will use to maybe generate the same message, right? So let me be a bit cheeky to just copy this thing. And because this is a UTF-8 string in Ethereum is UTF-8, so we convert UTF-8 to hex. Yeah, this two again. Hello, here. Okay. But I need to split the 0x out. There's an easier way to do this. UTF-8 to byte. Binary. Oh, you again. I don't know if this will work. Basically, this one will work. I just need to manually remove the 0x and the space because it's too long. So I'm going to pick a short sentence. I've decided. I think that is a good way. Yeah, I'm happy with that. So let's remove this one. I can't even copy out. Okay, let's remove. Obviously, there are better ways to do this. I'm just unprepared. Okay, copy and send to myself. Whatever works. Send to myself. Okay, I go to Coven. Let's wait. Let's give it a bit of time. I'm going to spam refresh this thing. What's so slow? How is so slow?
Not enough validators or miners on Coven probably.
Yeah, it's okay. It's back up. So we look at the input data and then we decode it. So I've decided. So that's how you send an input data in a transaction using MetaMask.
Yep. So I think we're at 5:32. We're a bit more than the 1 hour that was slotted. Are there any questions from anyone? There's a question.
Sure seems like we could scrap decoded data for insights. Do you think it's possible? Scrap decoded data. Well, because everything is in the blockchain anyway, so you can actually do it anyway. Unless you want to scrap Etherscan data. That is what you're referring to. You don't need to scrap. You really don't need to scrap. It's available publicly. Let me show you. Let me show you that it's available publicly. If you want to, if you're interested in this guy, right, for example, you don't need to scrap. You can just export as CSV, and then you give you all the data that you want. So don't need to scrap anything. Just export.
Oh, what's the API for this? I was looking at the Etherscan libraries a few days ago, but I don't see this specific
API for
to
API
just
for CSV?
call the decoded input.
Oh, so you're wondering how does Etherscan do this?
No, I just want to get I just want you to provide to me in the JSON as a JSON field. Do you have the API already?
Oh, this one? You mean
Yeah.
how does Etherscan do this? Etherscan, okay, I can answer this. I can answer it well. Etherscan don't do this manually because Etherscan relies on Web3. Web3 has a library that we can use. Just pass in the ABI and pass in the input data, you automatically spit this thing up. And I just format it into the format.
Okay.
So yeah, of course you can write your own, but Web3 has provided a nice library which I can use. So just use it. Oh, donate API, right? Donate API because this thing can be done offline. So you don't have to call an online source to get the data. You just do it offline. It's the download library. Can I explain how do we trace the method ID to the specific function from the contract? How? If I understand your question correctly, right? You want to know if a method ID, okay. You want to know if this method ID represents claim, right? What am I doing? How do I track? So number one, you look at the contract API. You convert every of the functions over there to the 4 bytes format, and then you see which one it matches, no? Because that's how EVM does it as well. So okay, got it, nice.
I have a question about applications again. So we did talk about it a little bit earlier, but I was wondering, knowing what we know today, right? What are the other applications we can build from this information? You talked a bit about 32 byte, the website that helps you quickly, given the meta ID, you can see, what are the no this one, the 32 byte, the 4 byte directory. Yes, that's the one. So
yes,
that's something that if I know the method ID, I can probably look up what it does without actually knowing anything further inside it. I need the API for everything else, right? But is there anything from today's information that helps me understand how to optimize my methods, for example, or anything for security? Yeah.
If you want to optimize method, something that I read was if there is a possible, if there's something you can do, right? Always use if you can always use bytes instead of bytes. This one, because if you understand how does bytes this one works, right? This one will append the offset by how many bytes and the length. You actually passing in more data to the function, and this one requires more gas to execute. Unfortunately, for input data, they don't pack the bytes. So if anything, it will be 32 bytes. And another thing that I've read is that data with more zeros are cheaper. So for example, if you are calling like maybe maybe this function has the type of uin 256, right? And another function has the type of in 256, so to say.
Yeah.
And this one we are only allowing user to maybe pass in like maybe 1 to 10. It's a small number. So maybe the user pass in 1. So it'll be a 0, 0, 0, 0, 0, whatever, 1, right? But if you're allowing wait, hang on, am I doing my math correctly? Okay, and then if you are allowing user to pass in this one, right? I think 1 will still be the same result, but if it's passing -1, it will be f. I think f all the way, because it's 2 complement. So if I'm not mistaken, f will be more expensive will be more gas expensive than calling 0. Non-zeros will be cheaper to call, if I'm not mistaken. So I'm not sure if this is what you mean.
Yeah, I get that part. I'll probably look into it a little bit further. One more last question about that part. Just knowing the method ID, knowing the input data doesn't tell me what the method actually does. I need to.
Yeah, it doesn't.
Right.
It doesn't. It's basically more on developers trying to, number one, gain more information on how things works.
Yeah.
Number two, if you are building something that maybe tracks the method ID,
yep.
You can do that.
Yep.
Basically, for normal users, I wouldn't expect much of a use case.
Right. So without the API or having access to the source code, I can't actually go any further.
Right. Yes, you cannot be 100% certain that the function looks like this or that.
Yeah. Okay. All right. Thanks.
Yeah. So it's more of a like you point like what you pointed out is more like it's more of fun. There's not much actual use case for normal Ethereum users.
All right. Thanks.
Yeah.
There are I think especially before the MEV stuff became big, like all these bot priority gas auction bot makers would actually look at obviously the contracts are not verified because they want to like keep it to themselves, but someone would actually try and interpret what is being done and basically create a copy out that whatever functions that those bots had.
Yeah, so probably reverse engineering stuff, Harif. But as you see, it's not going to be easy. But yeah, with time, maybe you can do it.
And with a lot of money at stake.
Yeah.
Okay, so I think that's a bit more than the time that we planned. We can end the call today. And for next week, next session, Chichuan, what will we be covering?
Event logs. We'll be talking about event logs.
And relevant items around that, I assume, topic 0 and
Yes.
so on.
Yeah, that's right. That's right.
Okay. Thanks for joining, guys, and we will see you next week.
Thank you for having me again. Thank you for spending your time on this workshop. And thanks, Arif, for the opportunity.